This is topic 5-3, writing linear equations, day 2. Today's objective is I can describe relationships for given problem situations and write equations. We're going to make that an essential question by writing how can I describe relationships for given problem situations and write equations. By the end of this lesson, you should be able to answer that question. A bulwark is to create a mapping using the words for x's and y's. In our first oval, we have our x's. In our second oval, we have the words that correspond with y. The word bank down at the bottom, input is an x. Range is a y. Inside is an x. Output is a y. Independent is an x. Outside is y. Domain goes with an x. And dependent goes with y. In order to be a complete map, we have to show where we're starting and where we end. So our x input corresponds with output in the y. Inside corresponds with outside. Independent corresponds with dependent. And domain goes with the range. Our map is now complete. When you fill in those words, you could have put them in any order. So with input, inside, independent, domain could go in any order as long as those 4 words are in that oval. Same with the y, range, output, outside, and dependent could have been put in any order as long as it includes those 4 words. But the main thing is making sure that when you draw your map, that the input goes with output, inside with outside, independent with dependent, and domain goes with the range. Our first example, because Tommy was grounded, his father made him shovel a pile containing 50 cubic feet of sand into a dump truck. With each scoop, he decreases the size of the pile by 1/5 of a cubic foot. So we need to find what the beginning point is and what the rate of change is. The beginning point is going to be where he starts off. So Tommy starts off with 50 cubic feet of sand. So our beginning point is he has 50 cubic feet of sand. Next we want to see is how does this change? Since he is taking away scoops and it says that he's decreasing, we know that the rate is going to be decreasing and is decreasing by 1/5 of each scoop. This is kind of backwards on how it's stated, but our rate of change is 1/5. Each scoop tells us, each is that word that tells us multiply, that we're going to be multiplying by the number of scoops. So the beginning is 50. Our rate of change is 1/5. So now we want to write the equation that could be used to determine the number of cubic feet left after x scoops. Part A actually tells us what variables we're going to be using. F is for the cubic feet left, and X represents the scoops. If we can figure out which one is going to be our input and which is going to be our output, that will help us in determining our equation. So figuring out what depends on what. Does the amount of cubic feet left depend on the number of scoops, or does the number of scoops depend on the feet? And it turns out that F, the scoops, is going to depend on, the feet left, the cubic feet left, depends on this number of scoops. So our cubic feet is our output. That's what we have left. and our scoops is our input. I'm putting an I underneath. So if F is our output, it is outside the equation or outside the equal sign all by itself. And we're going to follow the same pattern we did yesterday. With the pattern from yesterday, we had our process said we start with our beginning, and then we're either going to add or subtract what our rate of change was, and that rate is usually multiplied by something. And what's inside here is going to be, you'll figure that out because it's what follows the per or what follows the each in the problem. So getting our equation, we start with our beginning, that's 50. We know that it's decreasing, so that's negative or minus. Our rate of change is 1/5, and it is per scoop or each scoop because it says each scoop decreases by 1/5. So we're going to put the number of scoops is X, or the variable that represents the scoops is X. The independent variable, our independent is our I, and if we look up here, we said our I or our inside was X, so our independent is X, which is the number of scoops. That means the dependent is our outside. Our outside was F, so F represents the cubic feet left. If I look at my equation, we see F equals, the equals we can think of as depends on, and then X is the variable on the inside. So this will help with part D. F is our cubic feet left. And X is our number of scoops. Part E asks how many cubic feet were left after 10 scoops. The number that they give us is 10 scoops. 10 scoops represents our X. So we'll go back to our original equation. F equals 50 minus 1/5 X. And now we know that X equals 10. So let's substitute 50 minus 1/5. Instead of X, we're going to put 10 equals. Now we'll use our calculator in order to help us figure out what that number is. Bringing up your calculator, we have 50 minus, our fraction is 1 divided by 5. That's our 1/5. I put it in parentheses. And then what we substituted in was the 10. Press enter and we get 48. 48 represents F. And F is cubic feet left. So there are 48 cubic feet of sand left after he has taken out 10 scoops. Part F says write and solve an equation to find out how many scoops he shoveled when 20 cubic feet remain. So what they give us is 20 cubic feet remain. 20 cubic feet, that represents our F. If I go back up, F is the cubic feet left. We want to find out how many scoops. We want to find out what X is. So our equation, going back to our original equation, instead of F, we're going to put 20. That gives us 20 equals 50 minus 1/5 times X. Now we'll go through our steps of solving the equation. First step, and I don't have very much room, and I know you may not have very much room on your sheet, so I would suggest rewriting the problem on the back of your paper so that you have room in order to solve it. First step, we'll draw the line down the equal sign. Step 2 is do we have any parentheses? That answer is no. The next step, do we have terms that we can combine? Do we have terms we can combine? On our right side, we have an x and a 50. I can't combine those. On the left side, it's 20. It's by itself, so that's no. The next step asks, do you have variables on both sides of the equal sign? Nope, our x is only on one side. The next step then says to box in your term with the variable. So our term that's with the variable is a negative 1/5. The variable is x. Our next step, get rid of the number that is not in the box, but it's on the same side. The number not in the box on the same side as the equal sign is the 50. To get rid of it, we have to do the opposite, so we will subtract 50. 20 minus 50. Use my calculator just to make sure. 20 minus 50 equals negative 30. It is a negative number. 50 minus 50 is 0. I don't have to show it, but what I still have left is what's in the box. So I'll bring my box down. The last step says to do the opposite of the coefficient in the box. Our coefficient is a negative 1/5. It is being multiplied by x. So the opposite will be divide by. So we're going to divide by, and we divide by the number that's in the box. The number that's in the box is a negative 1/5. I'll put that in parentheses, negative 1/5. So in my calculator, I'll type in negative 30 divided by, open parenthesis, negative 1 divided by 5, close the parenthesis. That's what's on my left-hand side. Press enter. We get a positive 150. The right-hand side, those negative 1/5 will cancel. We're left with x. So those of you who still struggle with using fractions, I'm going to take this part of our equation, negative 30 equals a negative 1/5 x, and we're going to change that fraction to a decimal to see if that's easier to work with. So negative 1 divided by 5 gives us a negative 0.2. So this equation becomes negative 30 equals negative 0.2x. We still have our line. We still have our term with the x. Now to get rid of the negative 0.2, we have to do the opposite of multiplication, so that's division. We'll divide by negative 0.2. Divide both sides by negative 0.2. Using our calculator, can't forget the negative, negative 30 divided by a negative 0.2, and that is 150. The same answer we got in our previous, when we used fractions. So if x is 150, x represents the number of scoops. This tells you it takes 150 scoops to have 20 cubic feet remaining. Now that we've done our example, we're going to write our summary. Our summary is going to be based upon our essential question. And remember that the essential question had to do with your objective. So I'm going to go to a clear page. Our essential question was, how can I describe relationships for given problem situations and write equations? So if you're still struggling with coming up with what your summary is, let's start with the objective. The objective says, I can describe relationships for given problems given problem situations and write equations and then I'm going to put the word by. So now our objective is to figure out, how did we do that? In our previous problems, what exactly did we do? So I look back at the example. The first thing we did was we came up with what's the beginning point and the rate of change. So in order for me to describe these relationships of the given problems and write the equations, I need to find the beginning point and the rate of change. Then, because just finding those two bits of information doesn't write the equation for me. What the other thing we need to do is then afterwards we figured out what was our output and our input variables. And sometimes they gave the variables to us, and what we'll see is in other cases we're going to have to figure out what variables to use ourselves. But we need to know what's the output variable and what's the input variable. So we're going to put then determine the output slash input, that means both of them, variables. With that information, we can write our equation, because now we can write the equation by starting with the output, it's outside, equals to our beginning point plus or minus, depending on if we're increasing or decreasing, our rate of change times our input variable. So our output is equal to the beginning point plus or minus the rate of change times the input. And I'm going to go ahead and put the input in parentheses to know that's what we're inputting. This concludes topic 5-3, writing linear equations, day 2.